Thanks for having me here. Thank you, Cesium. Thank you, everyone, for coming. I hope I didn't offend anyone with my sea shanty singing earlier, if you saw that session. I'm not going to talk about that, but I am going to stay in the ocean with this talk. My name is Andrew Lunstad. I am Terradepth CTO, which means, as I shared before, I run the engineering teams. And what's interesting about Terradepth is that, well, a number of things to me, but with respect to this talk, is that we have really, included in our mission of helping humanity make better decisions about the ocean, we have kind of a natural environmental and economic sort of leaning, right? Because there's a lot of life on planet Earth that is dependent on the ocean, right? We get a significant portion of our food from it. It produces a significant portion of our oxygen, right? And we don't know, for the most part, what's happening underneath. So there's a lot that we can do, to enhance our knowledge of the ocean. And we already have a number of resources deployed in the ocean. For today's talk, though, I'm going to talk a little bit more about who is Terradepth. I'm going to cover disaster response and ocean survey. As you can imagine, we're talking probably more about ocean disasters here. We're going to talk about how we at Terradepth and how we enable partners to do mission planning in a Cesium-based, in a cloud platform. In our case, it's Absolute Ocean. And then we're going to talk about why autonomous is important, so why we're doing our robotics work at Terradepth and what that has to do with managing the carbon output of survey. All right, so Terradepth, as I mentioned, is an ocean company. We are both developing robot submarines to collect data from the ocean, as well as a platform to enable people to interact with ocean data better. Why is this important for... Oh, I forgot I put slides in here. This is a picture of our robot submarine. What it is it is a autonomous underwater vehicle, a robot submarine. It is capable of recharging, though, at the surface. So you'll see that there's a mast sticking up from the back. The reason that exists is because we will recharge while we're at sea and then dive back down to do more survey. What's important about that, we'll cover it a little more later, but it turns out this is more fuel efficient than larger survey vessels. We're also, in the meantime, using existing autonomous vehicles to collect data from the ocean, right? This is a picture of one of our offshore crews, and they've got a Gavia AUV in the water there that's developed by Teledyne, and they're using it to collect ocean data. I think this is at a wind farm. And then this is Absolute Ocean, right? If you saw the presentation earlier, you'll have seen some of these pictures before. The idea is that we're building a platform to allow people to see what's happening underneath the ocean. In fact, when we started working on Absolute Ocean with Cesium some years ago, there was no Cesium bathymetric data set, right? So we had to do this all from scratch, and we partnered with the folks at Cesium to help create the original version, which is what you see there. In addition to doing that, we also have a number of NOAA decommissioned data sets in our platform. This right here, I think, is a sediment depth map. It goes all around the world and allows you to see the sediment depth, I guess. I actually don't know that much about it. We just brought it in, and I thought it looked cool. And then we build other tools so that you can compare what you see using this split direction tool, is what it's called in Cesium, if you're looking to use something like that, in order to compare two different versions of the same area. So why is that important? Well, with disaster response and ocean survey, one of the things that you need to do is, after a hurricane, if you have assets in the sea, you have to check to see if they've been affected by by the hurricane. So let's see if this works here. Yep, there it goes. So one of the things that we've built into Cesium is a deep linking capability, so that we're on to Cesium, into Absolute Ocean, excuse me. And so we can bring up views that we have shared by clicking the share button here. But I'm going to shrink this now. Oh, that tells me that I got it. And then we're going to bring up the split direction tool, what we call our swipe tool here. So this is the Redbird reef sanctuary. It's an artificially developed reef. As you can probably tell, those are not natural objects that are on the bottom there. In fact, what they did is they sank a tanker and a number of subway cars. And they do this in order to create reefs, and reefs tend to attract fish, and then you get, underwater ecosystems that develop around it. After Hurricane Sandy, they resurveyed this area. This is the University of Delaware that did this work. And what you'll be able to see, the concern that you have with a hurricane is there can be scouring. So assets that are supposed to be buried, that are supposed to stay in place, may be moved by the strong currents that you get. And so if I drag this back and forth, you'll be able to see the left side of the swipe tool shows pre-Sandy and the right side post-Sandy. And so as I scrape or as I swing it over around these assets, you can see the scouring that happened after the survey, right? So for an artificial reef like this, it isn't a big deal. But the other images that we have of people's pipelines, I can't show you. So this is the one that I'm using as an example. But you can see what happens, right? The tremendous currents that we get when you have the winds and a hurricane like that create some scouring. And so that's one of the use cases for our platform that we developed and how we've used Cesium to implement it. Now let's see where it put. All right, so that's how we do kind of some before and after looking. But having a before and after view in order to look at a survey presupposes that you've actually collected some after information. So the thing about ocean survey is that a lot of the tools that you use were developed in the 1990s perhaps, and they're desktop tools that run on your pretty much only Windows computers. The user interface isn't great, and the integration with other tools that you want to use is difficult. And so what we found is that people who are doing mission planning to do a survey of where they think a pipeline is or a reef like I was just showing, they find that it's oftentimes the data that they want to use to help plan the survey ahead of time is, well, it exists, right? But they might not know where it is, and they might not have immediate access to the hard drive. So even professional survey teams will oftentimes have to put in a request weeks ahead of time in order to get that data delivered to them, right? Then they will bring it into their planning tools and then plan that survey on top of that imported data. But this is a long and laborious process. And if you're looking to do disaster response, you have to react quickly. So what we've done here, you know what, I'm just going to drag this over here. All right, so what I've done here is I've opened up a part of the Gulf here with our mission planning tool enabled. Now, this mission planning tool is not released to the public yet, but we're already using it internally for our autonomous submarine development. What this allows you to do is pull in resources, and here you can see the resources from this survey here that allow us to see, I don't know if you guys can see it there, but this is, there is a little yellow outline where we wanted to do our survey. Here, I'll zoom in a little bit. Right, so those of you who are familiar with using, Cesium tools, it works just like everything else in the platform. But what we've done in this case is we've built it to leave from this harbor here. We can send the vessel out, and we can plan this mission. We further then added the capability to, at any specific transit in that mission, let me move over here so you can see. Actually, let me select it this way. I'll just do it like this. As I select the various mission segments here, you can see that they'll highlight. And then what I can do is I can change things like the speed that I want to move. So you might want to transit faster when you're heading to the survey area, and then you'll want to go at a certain, at a speed that's optimized for survey. you'll want to change the depth, or you might want to set it to be terrain following, and then say, well, you don't want an altitude of 0. That's called crashing into the ground. You might want to set an altitude of 14 meters or feet. I forget what the unit is here. That's an open bug for us on our internal tool. And so what you can do then is you can bring in, if you can imagine the Redbird survey earlier, we could open up this tool and we could plan to do a survey over the area. Having seen some scouring afterwards, we could then, inside the same tool that we're using to look at that data, we could move around that area. By the way, I'm okay with questions as we go through it. And so if it's okay with the organizers, or if I can just restate your question, feel free to interrupt me. Okay, so that's a quick introduction to our survey tool. Here's what I think is really interesting about this, is we built this inside of the last year. And already within that time, we have someone who we've partnered with, another development company that we've partnered with, external to Terradepth, who said, we're building, and here, let me just switch out of this demo. There it is. We're building an application that controls autonomous surface vehicles in order to enable survey, not underwater like we do, but they'll send the vehicles along the surface. And they were using some existing pieces of software in order to do that planning. They said, would it be possible for us to try integrating with what you're doing? So that's what they did. So the company is called Spatialnetics. They came up with a product called LutraPilot, which uses a MAVLink protocol to control as many ASVs as you have access to in order to have a swarmed survey of an area. What they did then is they take advantage of Absolute Ocean, which allows the mission planners then to come in. Well, I think in this case they're showing that we developed Absolute Ocean. And then you do a mission plan, and in this case, I'm not sure exactly where that is, but it's a section of river. And they do the mission planning with NAO, and then they transfer our mission format into something that they can consume. There it is. And you can see their control panel for the product right on top of Absolute Ocean on the right side of the screen. And it allows them to track the mission. So if you'll look, and there's just a little piece of it here, if you see those yellow lines below, you'll notice that they look very similar to the completely straight survey lines here. But in this case, it's an actual autonomous surface vehicle following the same commands that were given in that survey. Okay? The way that it works is our product, Absolute Ocean, is running in the cloud. Their product, LutraPilot, is running on the shore next to where these ASVs are, and it's communicating over RF with the various ASVs. And then what's happening is in real time, their LutraPilot application is publishing web events through an API that we've developed into Absolute Ocean. Or they're publishing these events using calls or web events to Absolute Ocean, which in turn generates web events to every single browser that is tracking those same survey vessels inside that browser instance. So what it does then is instead of having one person tracking a mission on their PC, we've now developed a cloud-based architecture where you can have multiple users subscribing to these events. And as long as they have permission, right, they're able to consume that and track that mission on their PC. So this was enabled using online documentation, and I'll just quickly show you how that looks in our system. We've got, if you want to work with Absolute Ocean, we've got a full set of Swagger documentation or Open API-based documentation that allows you to build your own applications on top of this, assuming you have an account. And then what they've done with it, again, is like I said, they've using MAVLink, they can consume those same APIs to, number one, get the mission profile that they've developed in Absolute Ocean. Number two, they're using MAVLink to control their ASVs. And then they're able to build a custom application that takes advantage of everything that we've done, but now magnifies it by multiplicative adding value through what they did as well. And that is what, oh, one other thing that I wanted to cover. I mentioned earlier that we are building an autonomous underwater vehicle in order to save on carbon, right? And I've mentioned that autonomous vehicles in general are far lower carbon than other survey vessels. I wanted to take a little bit of time before I end to explain that. This is an offshore survey vessel. Okay, this one is owned by the Schmidt Ocean Foundation, and it's actually their original one, the Falkor. It can hold 400,000 gallons of diesel fuel, and with that, it can go and perform missions at sea over months, and that's great, right? There are some things that you need to do that way, but if you can achieve the same mission by sending, our autonomous vehicle to go down and do the mapping, instead of spending hundreds of thousands of gallons of diesel fuel, you're spending maybe 100 or 200 gallons to keep that submarine going because it's much smaller. On the other hand, there's also significant personnel savings when you can do it this way because, running a ship takes a number of people, especially when you're running multiple shifts, when you have to have a day captain, a night captain, someone to cook. You need deckhands for the day, deckhands for the night. You need the people who run the sensors. You've got to lift those AUVs on and drop them off. And so we really see this as an enabling technology for reducing the carbon footprint of ocean operations. And that, I believe, is the last thing that I wanted to talk about. So I'll just end with this cool video that we had produced that is a flyover of our submarine. And you'll be able to see as it pans up over the top of it how we have a little Mandalorian-looking helmet on the top of that mast that keeps the seaweed out of our mast when it's underwater and can draw in air so that we can recharge when we're at the surface. And that's all I had.